Hello, good morning to all. Today we are going to see about the cellular concept. So, what is cellular concept? It is a system level approach to replace single high power transmitter by many low power transmitters, each providing coverage to a small geographical region. So, suppose you assume you are having a large geographical area, a large service area. So, in here you can place a large transmitter so that can cover the larger region. But in this cellular concept, now you are going to use a number of low power transmitters instead of a single high power transmitters, and this large geographical area in here will be divided into number of cells. So why we are doing this means it solves two problems, that is a spectral congestion as well as the user capacity. These are the two problems. So as the number of users is increasing, you'll be need to provide more frequencies. Another one thing is, if a larger cell is used and a single transmitter is placed, means all the frequencies will be alerted to the single transmitter, and it will be allocating the frequencies throughout the entire geographical region. So spectral congestion will be there, and only one time the whole range of frequencies is used, but day by day the users are increasing, so we have to meet all the demands of it. So spectral congestion and user capacity problems are solved by the cellular concept. In here, each base station will be allotted a portion of the total available channels. So what about the neighboring base station means they'll be allotted a different group of channels. So why this is done means interference is minimized because the neighbors are not allotted the same group of channels. So overlapping of frequencies or overlapping of signals will not occur. So by this I am reducing the interference. Then what is the principle of wireless communication? So when the demand increases, we have to use more base stations. That is, the number of base stations has to be increased in order to meet over the increasing demand or the capacity. At the same time, the radio spectrum, there should not be any increase in the usage of radio spectrum. That the same amount of radio spectrum has to be used. This is the principle of wireless communication. Then an important concept in wireless communication is frequency reuse or frequency planning. So how will you define this? It is a design process of selecting and allocating channel groups for all cellular base stations within a system. See, a number of channels or frequencies available. We have to select it and allocate to a cells, because the entire geographical area is divided into a number of cells like G, B, C, A, F, E, D and so on. So for each and every cells, a group of channels has to be, or frequencies has to be allocated. Next is, the cells are represented by using the hexagonal shape. Why this hexagonal shape is preferred? Means if I am using a circle, means in order to cover the entire geographical area, I'll be using a number of circles. So there is a possibility of overlapping of the adjacent circles, because we have to cover the entire region by using the number of circles. If they are not overlapping, means some of the portions will be left uncovered. In order to cover the entire area, I'll be using circles, so there will be a possibility of overlapping. So this is the usage of this circle as a geometrical shape to represent a geographical area is eliminated, as there is overlapping. Other choices are, what are the other choices means, without any overlap and having an equal area means they are equilateral triangle, square and hexagon. Among the equilateral triangle, square and hexagon, hexagon is having a larger area for the distance between center and farthest perimeter points. So since it is having a larger area, we can opt for it. Another one thing is it approximates a circle. So mostly omnidirectional radiation pattern is preferred. So in a circle, omnidirectional pattern is possible. In since hexagonal is somewhat similar to a circle, in here too omnidirectional radiation as pattern is possible. An important advantage of this, when I'm using the hexagonal shaped cells, I'll be requiring only few hexagons to cover the entire region. This is yet another advantage if I use a hexagonal cells. So what is a cell means a small geographical region is called a cell. Then see, as per this diagram, in here I have used a cell which has been named with a capital letter A. Similarly, there is another one cell named by using the capital letter A. So this implies they are named with the same letters. It implies that this cell as well as this cell will be utilizing the same frequencies. But what about this G, B, C, D, A, F means they will be using a different frequencies when you compare to its neighbors. Then footprint. What is footprint? The actual coverage area of a cell is called footprint. So why it is important means I am having a cell. In the cell I will be having a base station. This should be able to cover the weakest mobile. So what is the weakest mobile? Any mobile located at the edge of a cell is called the weakest mobile. So the base station should be able to send signal to the weakest mobile, but that weakest mobile should be within the footprint, within the actual coverage area of a cell. Then where do we place the transmitters? In the hexagonal layout, there are two possibilities. It can be placed at the center of a cell. Those cells are called center excited cells. Here omnidirectional antennas are used. Another case is edge excited cells, because in hexagon 3 vertices are there. So among the 6 vertices are there. Among the 6 vertices, 3 can be utilized, and in the 3 vertices I can place sector directional antennas in order to give the signals. Next, practically what is done means the base station transmitters are located up to 1/4 of the cell radius away from the ideal location. Then there are some terms. Yes, is the duplex channels available in the system. What do you mean by duplex? That is anything. Duplex channels means two-way communication must be possible between the transmitter and receiver simultaneously. Those channels are called duplex channels, we say. Then what is the number of channels or frequencies that is allocated to each cell or group means K. That K should be less than the total available channels. So the total number of available channels is equal to S is equal to K into N. Then what is N? N cells. It forms a cluster, or it can be called as a cluster size, I say. So whether a cluster is used for a single time or it is going to replicate it many times means yes, it is replicated for m times. So as per the frequency reuse concept, it has to be the range of frequencies has to be replicated. The number of frequencies or channels that will be used for the cells has to be replicated. So total number of duplex channels C is equal to C is also called as a capacity, that is equal to MKN. That can be simplified to MS. Then what will happen if I change the cluster size? Suppose if I am reducing the cluster size, that is N is reduced, but I am keeping the cell size as constant. I am not changing the size of the cell. So what happens is more clusters will be needed to cover the larger area. So what does larger value of N mean? It means that ratio of cell radius and distance between the core channel cells is small. Then suppose if I am reducing the N value, what will happen means the core channel cells will be very close to each other. Core channel cells will be placed very close to each other. Then N is also a function of interference tolerance. Depending upon N, interference tolerance can vary. So next is, suppose if I am utilizing a small value of N means I can get more capacity. Frequency reuse factor. So what is frequency reuse factor? Means 1 by N. That is, each cell is assigned 1 by N of the channels. That is called reuse factor. So how the cells should be placed? The adjacent cells should be placed and there should not be any gap. For that we need a condition. N is equal to I square plus Ij plus J square. So what is this I and J? See, this is a geographical area. I have placed a number of hexagons. So we have taken the cell A. It is utilizing some set of frequencies. Yeah. In 7 cells are named the same letter A. It implies that they are going to use the same set of channels or frequencies. So how they are selected? Why not here, or why not the adjacent cell? But it is that the cells are a little bit far apart. How the distance is fixed? That is, first step, we have to move I cells along any chain of hexagons. Move I cells along any chain of hexagons. In here I have taken I is equal to 3. So I have moved 3 cells along the chain of hexagons. Then you have to turn 60 degree in a counterclockwise manner or anti-clockwise manner and move for J cells. That is, here I have taken J is equal to 2. So for 2 cells I have moved. First 3 cells along the chain of hexagons. Then some rotation of 60 degree in a anti-clockwise manner I have taken. Then I have moved J, that is 2 cells. So now N is equal to 19. So after 19 the cells, I can place the co-channel neighbors. Thank you.